Morning. My voice is rapidly leaving me, so this is going to be a very quick video going through the poll results for the Week 5B poll from Fall 2023. Skipping right to it. The first question is a slightly more complex version, just because it uses an if and an else statement of what you've previously seen in your homework. Now, the major thing to notice is that we have two main inputs to this code, the URL and the file name inside of the zip file. So it's kind of like the file expected to be inside of the zip file. It first checked to see, has this file already been downloaded and extracted from that zip file? If so, then it prints off this message, skips all of this, and jumps right to reading the object in. On the other hand, if this is false, and it does exactly what it sounds like, does true or false, does the file exist? So if this returns false, this code gets run. That's an else. That's the concept of an else statement. So this file gets run. It first creates a zip file name based off of this name. So this would be chromosome4.depth.out.zip. It downloads from the URL, stores it at that zip file name, unzips that file, and expects this file name object. That's actually intentional. It doesn't require this. However, if that file name doesn't exist inside the zip file, that returns an error, which can just be useful for students trying to understand why something's not working. For instance, if you had added the wrong address, or maybe if I messed up and sent you the wrong email. I think actually this year it happened that one of my collaborators who was originally hosting this file, their box address seems to have changed. I don't know what's going on their end, but that would be an issue. So didn't really affect many people, but there you go. So looking through these answer choices, the argument sent to if, so that's what this all resolves to, would be false. So the file would download. That's going to be true if the file has not been previously downloaded and technically unzipped, downloaded and unzipped. Let's actually add that in. Not been previously downloaded and unzipped. There you go. The rest of these, the argument would be true. So that's not true. It hadn't been downloaded yet. The file shouldn't exist. So it wouldn't do this code anyways, except this would have been the wrong outcome. If the argument was true, this would get printed. So this is a valid option after it's run. If this is false, the print code would not run. So this isn't a valid option at any point. Neither is this one. This is a valid option if the file has already been downloaded. Cool, moving forward. I think most people got that one right. The following code produces, again, geez, I was sick when I wrote this. It shows an error and does not successfully extract the rows where the read depth is greater than 10. Why? Okay, so the major issue is that this is, I think it's a 250,000 value of logical values. So true or false is the read depth in that third column greater than 10. That's a huge vector. It's much longer than the 3 columns that we now know this object has. So in terms of what's the answer, this produces a logical vector that is too long for the dimension being extracted. Totally true. Weirdly worded. Depending on your version of R, you get a message that's more or less like this one. I believe the current version of R, it just says undefined dimensions, which isn't quite as interpretable. But there you go. This is definitely true. Square brackets with a comma totally works on two-dimensional objects like data frames and matrices. It also extracts rows with a read depth equal to 10. That's not true. That would be if there was an equal sign here. And if it was functional, it's not functional. And Nolan is a dirty liar, but that's beyond the point. All right, this next one. What rows would the following return? Okay, so it's doing some logic. break it down into individual pieces. Students just keep getting lost. A lot of this practice with R comes down to kind of learning some strategies of order of operations. So for instance, I can't use this pipe, which is a comparison, an operator that compares logical vectors until it's got logical vectors on either side. Consequently, the people who write R made it lower, like further in the future, in terms of order of operations compared to things like equals equals, because you often want to make a comparison to generate a logical vector, make a comparison to generate a logical vector, and then compare those logical vectors. It's only logical that the pipe symbol would have a lower order of operations. Now, if you had, say, been on a test and asked me, I probably would have just said, yeah, that's how the order of operations work. Because I think in an ideal world, I would probably have added parentheses on here just to be like 100% confident that you have a solvable issue without having memorized all of the order of operations subtleties. But I mean, even within that, you still have to know certain subtleties, like this extraction occurs before the equals equals. Otherwise, you would get an error message saying V1 is not an object. Well, V1 isn't an object. It's true. It is a section of this object. And so it has to go off first. So this extraction occurs, this extraction followed by this extraction. So this is going to pull out, I think, chromosome 4 group 1. And then this will pull out all of those contig values and then say where they're equal. So you're going to get like true, 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 and then a whole lot of falses. On the other side, you're going to get the opposite. You're going to extract the last value from that column, which I think is chromosome 4 group 5, right? Group 5, I think that's how many groups there are. And then you compare it to that whole column, so it's going to be a whole lot of falses. And then I think it's like 50,000 trues. You then compare them to each other. And so at this point, you would have trues and then falses. And here you would have falses and then trues. There's a long stretch where both are false. So chromosome 4 group 2, 3, and 4 would all just be false in both systems. And so your resulting logical object will be like true, 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 true 50,000 times. Then false 150,000 times. And then true again 50 more thousand times. So that's rows where the V1 value is either true, where the V1 value is either the first or last value in V1. So literally, or this. And then you are extracting based upon the rows object, and that's why it's rows and not just like single values. Although I didn't actually make that an option. The next one is saying which of the following would the code return, and I give you a hint. I show you that A coerces to A unexpectedly. 1 coerces to 1, maybe somewhat unexpectedly, but hopefully you've gathered that by now. And then true coerces directly to TRUE. That's as opposed to maybe like being first coerced into a number, so 1, and then being coerced into the character 1. That's just not how the people who wrote this process wrote it. Instead, it just kind of goes all in one step. How can I go from logical to character? Well, represent true as TRUE. Consequently, it's not in these objects. A is, B is, 1 is, but true is not. I think it's fairly obvious that the ampersand and the exclamation point won't be in these objects, so those are going to be false. So the resulting object will be false, true, 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 false, because that's not in these objects, false. So 3 trues and a length 6 object. Good, Key was right. The very common mistake is to flip this around and say for each of these values, was it inside of these? But that's just not how it's written. What I recommend you do is just practice reading this out loud. It says, for each of these values, are they in the values to the right? That's how I remember it. This next question says, which part of test-vec match just the first dot, asterisk, and underscore parts of the pattern? Now, I have to be honest, originally, this question did not have a good solution because I only had an option before I changed it to just the first part of the pattern. I'm taking the sick. Listen to my voice. Listen how sad I am. I'm very, very sad and so sick. It's probably just allergies, actually, as far as I can tell. But I still feel sick. I'm still a little bit out of it. Anyways, if we go through, this example, this is signifying the beginning, so we know that no matter what, the first part of this, so like if you were capturing this dot asterisk, it had to start at the beginning. And then it said, and I probably should clarify that too, and the first underscore parts of the pattern. So if that's the case, then the second dot asterisk and the second underscore are not part of what I'm searching for. In that situation, it's actually it's easier to kind of work backwards. But let's try it from the front. So if this is the beginning right here, it's going to extend as far as it can, because that's the default behavior for a non-lazy or greedy asterisk. So it's going to do as far as it can to end at a underscore. So you would think it could go here. However, that would not be a match because the rest of the pattern would no longer be able to fit. I couldn't then have a dot asterisk followed by an underscore because there is no additional underscore for it to eventually reach. And that's why I say it's almost easier to work backwards, because this right underscore has to be this one, which means that the furthest extension that it could make is this underscore right here. So your correct answer would be this one. So just in recap, it is lazy, but it's going to go as far as it can in order to complete the match. That ends up being here because then there is any character any number of times to reach another underscore that is needed to complete the pattern. This next question was written correctly, for the record. But it says, which part of test-vec matched the first dot, asterisk, question mark, and the first underscore? So I've rewritten it just to help clarify that issue. I don't want where this section is matching. So in this situation, here is the beginning, here is any character, here is the underscore. That's a complete match, and because this is a lazy match, it stops. So that is actually the end, right? By itself, that's the answer. It then, in the actual thing, we can see that it's replaced, I hope, underscore. And that's because that is the second match. Dot, asterisk, question mark, underscore is going to extend this in as few characters as possible to end the match here. So this is the final underscore. There you go. For this question, we have this data frame, and then I'm going to look at its head. I can see that I've changed the lowercase b that should be here to a 2. So I'm looking for a code that is replacing just that value. The answers are going to be this one and this one. And the reason why is they're the only ones that successfully extract just that information. It's a little bit easier if I just pull up my feedback for this question, because I've already written out all of the things that are happening. So for this one, it extracts the y column. So that's going to be a vector at that point. So now it's using a vector-based extraction method, and it replaces b with 2. Cool. Easy enough. That's just a logical vector and then assigning to that. And yes, you can just string these extraction tools together. Someone very clever has written it so that it works that way. This next one doesn't work because df1 $y produces a vector first, which means it's a one-dimensional object, and this comma will throw an error. It's not two-dimensional. You get an error, something about the number of dimensions. That's the exact same problem here, regardless of whether or not the inside logic made sense. It doesn't work because this object is not two-dimensional. I can't rely upon rows and columns. I had to have used a vector style extraction. This next one ends up extracting the whole second column, and that's because of some funkiness in how R utilizes logical vectors. I do generally recommend you don't use logical vectors directly when doing an extraction. I know I demonstrated here. It is very common. The problem is it just has some very counterintuitive behaviors in base R, and it's just more of a safety precaution rather than like a necessitated problem. But that's what's happening here, is that you are sending it false, true, and then a whole lot of falses. But because the second one is true, it ends up extracting the second column and replacing all of it with 2. A similar situation happens here, except this time it is like the right length of vector, and so it's a little bit of a predictable result. This extracts the entire second row. Now, for the record, that doesn't return a vector. That does return a 3-column, right? Yeah, 3-column data frame, but it still ends up replacing the whole second row with just the value 2. So again, not what I wanted. Here, I am referring to the column's name as Y, except I've stuck it into the row section, which has this I did not predict this, actually. I thought this was just going to return an error. It creates a new row named Y and assigns 2 to its second column. And the reason why that did is because this was a wrong length logical vector, but the second value was 2. Wild result. Very tricky to understand, but you can go play with it, and hopefully that will make more sense why that happened. Obviously not what I wanted to happen. This is the right scenario. Extract the second row, also extracting the Y column, so this one also works. And that's it. Hopefully that helped. Let me know if you have any questions.